Good morning, good afternoon, and good evening for everyone joining us today in this virtual and global webinar, Mitigation Strategies to Reduce Local Ozone Impacts on Climate. It is a pleasure to welcome you to this relevant step in the fight against climate change, addressing short-lived climate forces, specifically tropospheric ozone. My name is Rodolfo Lassi, and I have the honor of serving as the moderator for this event today. I'm also proud to collaborate with the Cleaner Institute in the critical effort to reduce ozone pollution and its precursors that pose a severe threat to public health, the climate, and ecosystems. Together, we aim today to shed light on actionable strategies to mitigate this super pollutant and drive meaningful progress in climate and air quality improvements. Thank you very much indeed for being part of this essential dialogue. And let me take a moment to share some important housekeeping announcements. You will have the opportunity to engage with our distinguished specialists and policymakers by submitting your questions in the chat of this webinar. And we encourage you to use the Q&A function to submit your questions at any time during the presentation or panel discussion. Before we proceed with the first speaker, I would like to highlight that you are in a virtual pavilion on tropospheric ozone, created with the support of the Cleaner Fund and the lead participation of the Cleaner Institute, the Cleaner Task Force, and Health Consulting. Let's begin with the introduction of Dr. Citeli Sompa, a distinguished member of the scientific team at the Cleaner Task Force. Dr. Sompa holds a PhD in atmospheric science from Colorado State University, where her research focuses on emissions from the oil and gas sector and their impacts on tropospheric ozone and other secondary chemical species. She also had the privilege of working alongside Nobel laureate Dr. Mario Molina, contributing to the groundbreaking work in atmospheric sciences. With that, I'm pleased to hand the floor to Dr. Citeli Sompa, the lead author of the report, The Case of Action on Tropospheric Ozone, that we published as a policy brief last year during the COP29 in Baku, but now you can find the full report in our virtual pavilion. Citeli, the floor is yours.
Thank you so much, Rodolfo. Sorry for my voice, I'm a bit sick, but and thank you for the kind introduction. My name is Citeli Sompa, and I am a research manager at the Cleaner Task Force. It is an honor to be here among such distinguished colleagues and partners. And today I will present work that was funded by the Cleaner Fund and developed by the Cleaner Institute, Health Consulting, and the Cleaner Task Force. I will focus on local impacts of tropospheric ozone that are identified and will be published in the full report of the Case for Action on Tropospheric Ozone, just like Rodolfo mentioned. And this report will be launched next month at the CCAC annual meeting, so please stay tuned. And just to give you a little bit of background, the policy brief of this report was actually presented at the COP29 last year in Baku, Azerbaijan. So briefly, for those who don't know the Cleaner Task Force, we are a climate nonprofit organization with staff working all over the world. Our primary focus is to develop science-based climate policies in collaboration with governments and national institutions. So let's start with the basics about ozone. And it turns out there are two types of ozone in the atmosphere. One that is good to all living things in the earth because it protects us from the UV rays of the sun, and that stays high up in the atmosphere in a layer called the stratosphere. And a second one that concentrates at lower levels called tropospheric ozone. And that is considered bad because it contributes to warming our planet, harming human health, and threatening food security globally. In the troposphere, high ozone levels appear as toxic photochemical smog, which is the brown haze that is often seen above polluted cities. Tropospheric ozone is not emitted, but rather formed in the atmosphere, and its formation is determined by atmospheric concentrations of a suite of pollutants that interact with sunlight, and its chemical production is highly dependent on temperature. Excuse me. In fact, recent studies around the world have shown that higher temperatures increase chemical reaction rates and reactivity, which facilitates ozone formation. This means that warmer temperatures linked to climate change and are helping to drive periodic episodes of significantly elevated tropospheric ozone levels, resulting in a vicious feedback loop. And how that works? Well, it turns out that tropospheric ozone is a greenhouse gas that is responsible for almost a quarter of a degree Celsius of present day warming. And because it is one of the superpollutants driving half of global warming, rapid action is crucial to curb climate change and avoid climate tipping points. An interesting finding is that cutting superpollutants, which include tropospheric ozone, can mitigate warming nearly 4 times faster than decarbonization alone by the year 2050. In fact, we know that the climate effects of tropospheric ozone are felt most strongly in regions where levels are highest. In India, increases in tropospheric ozone are felt most strongly in regions where the levels have increased over the last couple of decades. And those increases of tropospheric ozone are associated with localized warming up to an estimated of 0.5 degrees Celsius. And a similar warming effect has been documented in China as well. But warming is just one of the tropospheric ozone local climate impacts. It is also linked to changes in the East Asia summer monsoon, and it has contributed to ocean warming as well, accounting for 18% of the historical warming observed in the Southern Ocean. This warming trend has had significant consequences, including contributing to the melting of Antarctic ice, which is a key cause of rising sea levels. From a public perspective, not surprisingly, the highest impacts of tropospheric ozone also correspond to regions with the highest ozone levels. Together, all Asia and Oceania are the regions with the highest number of ozone attributable premature deaths, accounting for almost 85% of the total worldwide. And tropospheric ozone contributes to respiratory illnesses, reduces lung function, and exacerbate chronic conditions like asthma, bronchitis, and emphysema. It has also been linked to complications in type 2 diabetes and cardiovascular disease. Alarmingly, 90% of the world population is exposed to tropospheric ozone levels that exceed WHO guidelines level, which cause almost 500,000 premature deaths each year, with conservative estimates of associated costs around $500 billion per year. And moving on, tropospheric ozone also affects vegetation, causing oxidative stress that results in plants being more vulnerable to stressors like plagues and droughts, and also resulting in important crop losses. Globally, it is estimated that losses of crop yields account for up to 26% of sensitive staple crops, such as rice, maize, and wheat, in which billions of people rely on. And following current ozone levels, impacts are highest in Asia, with wheat being the most affected crop. Farmers in that region can lose up to one-third of the total crop yield of wheat, and such impact can have large consequences in food security in this region. So what can we do to reduce tropospheric ozone? As explained before, ozone is formed in the troposphere as a consequence of emissions of pollutants called precursors, which include nitrogen oxides, volatile organic compounds, carbon monoxide, and methane, who is also a potent greenhouse gas. Therefore, the way to reduce tropospheric ozone is by reducing emissions of its precursors. The good news is that there are strategies for shared emission sources, meaning that a single source can emit various pollutants, and some of them can be ozone precursors, but also there can be other greenhouse gases and particles. And because all of them pollute our atmosphere, by having a multi-pollutant and integrated approach to both climate change and air pollution, we can reduce tropospheric ozone levels while benefiting from the climate and air quality reduction that comes from other pollutants. By doing so, we will be helping achieving net zero and decarbonization targets together. In our full report, we describe 4 examples from around the world where important mitigation strategies have been undertaken under the last decades. Later in this webinar, you will hear from 2 of the selected cities in the report, Los Angeles and Mexico City, more about their ozone prevention and control programs. In our analysis, we identified the following key learnings that could help other regions when addressing tropospheric ozone. It is the number one is that it is critical to have a strong political will where economic, technological, and human resources are specifically allocated for this matter. Second, it is essential to have coordination and cooperation between multiple actors. Third, there needs to be a comprehensive scientific information that comes from local and continuously collected data. And fourth, it is important to have regional and local emission inventories that include both greenhouse gases and air quality pollutants. Altogether, these examples taught us that atmospheric ozone can be addressed under different realities, but collaboration and information are key elements to do so. And with that, I thank you all for your attention.
Thank you, Citeli. Thank you for your brilliant and concise presentation of the most recent ozone report that we have in this community. I hope you get better soon from your flu and sore throat. It is now our privilege to welcome a panel of distinguished experts and policymakers, indeed, who will bring invaluable perspectives on how to reduce tropospheric ozone and the concentration of its precursors from their sectorial sources, but also from the urban and rural areas. Joining us today are Dr. Pablo Cicero from the California Air Resources Board and the City of Los Angeles, Patricia Camacho, the Air Quality Projects Director at the Mexico City Government, and Dr. Juan Mata, an international consultant and expert on air pollution and energy problems. Each of them will deliver a presentation. Let's begin with Dr. Cicero. Dr. Cicero holds a PhD in environmental sciences and engineering from UCLA, from the University of California in Los Angeles, where he has served as an adjunct assistant professor at the School of Public Health, teaching and conducting research on air quality, air pollution control, and exposure assessment. He was also a member of the Hagen-Smith Laboratory at the California Air Resources Board, focusing on mobile source emissions control. And in this role, he served, and this is very important, he served as the project engineer for the test plant that exposed the Dieselgate. the Volkswagen defeat device emissions scandal. If I am not mistaken, Dr. Cicero can tell us a little bit about that. It was the most significant case in the history of air quality management in the whole planet, resulting in almost $25 billion fine. The excessive, of course, nitrogen oxide emissions were particularly critical, highlighting the severe environmental and public health implications of this violation. I think that this is a problem that we are still facing in several countries. Well, currently he serves as an advisor and board member of the Cleaner Institute. Dr. Cicero, the floor is yours.
Thank you very much, Dr. Lassi. Indeed, it was a very interesting case, the case of Volkswagen. We knew we were in a good track when the German engineers from Volkswagen started to curse in German. So we say, oh, this is a good track. But today I'm going to be talking about a little bit of the history of Los Angeles and the South Coast Air Quality Basin, the South Coast Air Basin, where ozone issues were first discovered by Dr. Arie Hagensmith. And I would like, could you please put the first slide?
Yes, let me share my screen.
Thank you, Karen. And indeed, it's an honor to be here in this morning for me. It's 6 a.m. here in Los Angeles. So this background is from Los Angeles in a not a very good day. Not a long time ago, the fight for clean air in Los Angeles started in the mid 40s, and this is a brief chronology. Please, next one. Okay, so during the World War II, everyone was focusing on defeating the Axis. But indeed, we had an internal enemy that they were not the Japanese, nor the Germans, nor the Italians. It was the smog. So very severe episodes were found in Los Angeles during that time. And there was a different type of smoke than the London killer fog that is basically particulate matter and sulfur dioxide. This was something different, and we didn't know exactly what it was. So at the beginning, the culprit thought it was the industry. And by 1947, it was created the Los Angeles County Air Pollution Control District. So it was the first air pollution control district, I believe, in the world. And at that time, Arie Hagensmith, a professor at Caltech University from the Netherlands, started examining plants, and he discovered that this smoke, which is more like a photochemical contaminant rather than smoke, which is smoke and fog, started to discover that the plants were started to show damages in the leaves. So during the 50s, Hagensmith was able to link ozone to plant injuries and to automotive emissions. Before that, the main culprits were considered the big factories and refineries and burning of backyard waste, but it was elucidated that the auto emissions were having an important impact on the creation of ozone. As was just mentioned, ozone is not a primary pollutant, it's a secondary pollutant. Primary pollutants are the ones that are immediately emitted into the atmosphere. Ozone is created by the combination of hydrocarbons in the atmosphere plus nitrogen oxides and UV light or sun. And one of the good things that we have in Los Angeles is we have plenty of sun. We have a Mediterranean weather. So the combination was very good. As just mentioned, also meteorological factors are an important part of the creation of ozone. And then we're surrounded by mountains. So we had confined spaces for the cooking of the photochemical species. So we had the perfect environment for that. So at the very beginning, it was Los Angeles, but ozone and air pollutants, they have no boundaries. They don't know about the boundaries, so they were spreading through the other 4 counties of Los Angeles. We have San Bernardino County, Riverside County, and Orange County, which is famous for the initial Disneyland. It was here in Orange County. So by 1959, it was created the California Motor Vehicle Pollution Control Board. So once identified that vehicles were an important part of the problem, then it was created this Vehicle Pollution Control Board. By 1959, there was created statewide air quality standards, the first in the nation, and focusing on health effects. In the meantime, scientists at the local universities were studying the harmful effects of air pollutants. By 1963, the first emission control device was required from new vehicles, crankcase. So no emissions were emitted. Well, some of the emissions were emitted into the atmosphere, but they were controlled by recirculating them and burning them in a better way. Hydrocarbons emitted from the exhaust are poorly burned gasoline products, okay? So 1963, first emissions control devices are required in new vehicles. And it was tried to be retrofitted, but it didn't work. By 1966, in California, hydrocarbons and CO or carbon monoxide exhaust emissions were incorporated into the law for California. By 1967, the California Air Resources Board is created by Governor Reagan. So preceding the creation of the United States Environmental Protection Agency by 1 year, who was created by President Nixon. Then by 1971, the first NOx exhaust emission was created for passenger cars. So we had the other key component for controlling air pollution. Now, in the meantime, there are some local regulations for fixed sources or industries of all kinds. So we have the combination of NOx and hydrocarbon control emissions. Catalytic converters are installed in passenger cars with a big resistance from the auto industry due to the cost Just a little bit earlier in 1972, the World Health Organization published the air quality criteria and guides for urban air pollutants. So it was out in the public and in the world that air pollution was needed for all the urban areas. Now, again, air pollution doesn't know about boundaries, but also impacts the suburban areas and the regional areas, okay? So introduction of the catalytic converter for passenger cars are introduced 1976. All the air pollution control districts of the region, the Los Angeles County Air Pollution Control District, the Riverside County, the San Bernardino County, and the Orange County Air Pollution Control Districts are amalgamated into the South Coast Air Quality Management District. So it just happened that the Los Angeles air pollution was carried by the wind to Riverside and San Bernardino. So the people in San Bernardino and Riverside complained that they couldn't control the precursors nor the ozone formed somewhere else in the basin. So South Coast Air Quality Management District is created, and starts with different campaigns to reduce pollution from mobile sources, which are vehicles, and mostly in passenger cars, from industry, refineries. We have for one example of the point sources, and for area sources, including landfills or agricultural places. So it was introduced in 1987. There was clear that not all the measures have to be done specifically in the sources. We have some management campaigns, like, for example, the issue of the carpool or the ride share or the transit. So it was incentivized that all the people would share their vehicle and transport their vehicle, and industry and commercial places were incentivized to do so. This was refocused to new measurements in 1995. Industry and commercial sector complained that it was too expensive. So they started to give flexibility, like 1 day at the office only, or I'm sorry, 1 day not going to the office, keeping the ride share and other measurements. By 1989, the first air quality management plan was adopted. It's better when you have something in writing with clear goals and clear chronology. And one of the things about this is that the air quality of a region is linked to the National Ambient Air Quality Standards, which is overseen ultimately by EPA. And you need to be in compliance with the air quality standards. If you don't comply, then you lose funds for transportation in your area. So you have to say when you're going to comply with the air quality standards. Now, the air quality standards have been changing or have been revising since installation, and we started with air quality standards for ozone for 1 hour, and then we moved to 8 hours, running averages for 8 hours to be compliant. And then by 1991, it was published the seminal work, Rethinking the Ozone Problem in Urban and Regional Air Pollution. In this publication, all the complexities of ozone formation was addressed by the National Research Council. It was expressed in this publication, which, by the way, is online. You can check it and Googling Rethinking the Ozone Problem in Urban Regional Air Pollution, and you'll find the publication. It also stated that meteorology play an important part and climatology play an important part in the creation of ozone. It was stated the strong relationship between ozone formation and temperature. For those who know a little bit of synetics, would know the Arrhenius issue, which is that the higher temperature, your chemical reaction would go faster. By 1993, incentives were created. The Regional Clean Air Incentives Market, or RECLAIM, was adopted, where in the RECLAIM program, you could control your facility as a whole. It's also called the bubble approach. You put a bubble on top of your industry or your facility, and then you are able to control in the most efficient way. If, for example, changing fuels in one part or changing the processes in another is more effective than changing a device, then you can do that by having a bubble on top of your facility and control that way. And then if you control beyond what you are required, then you can sell those credits. So that's the initial establishment on credits. We use now carbon credits for global climatic change. That was one of the initial uses of the bubble principle. And then we have the seminal incentive program, the Carl-Moyer program, which gives money to early adopters and cost-effective controls. And these incentives have been diversified. Now we have some mitigation funds from the Volkswagen scandal. Part of the settlement was that to provide money to incentivize early adoption or cleaner technologies. And then in 2006, Governor Schwarzenegger instated the Global Warming Solution Act, also known as AB 32. That was the first act to control global warming or climate change in the nation, and these set specific standards for greenhouse gases emission for California and targeting neutrality for 1990, I think. I'm not absolutely sure. So this is a brief chronology of the issues of the air pollution in Los Angeles. And I have to say that in Los Angeles, we have the different levels of governance in Los Angeles. We have the local level, which is specific cities. Then we have the regional area, which would be the South Coast Air Quality Management District. And then above that is the California Air Resources Board, which is in charge of submitting the plans to EPA, the federal agency, the U.S. Environmental Protection Agency, achieving the goals. Okay. Next one, please.
Dr. Cicero, we will have another 5 minutes.
Okay.
You have a very interesting presentation. Can you speed up a little bit your presentation? Thank you very much.
Absolutely, Dr. Lassie. I get carried away. Sorry. Well, this is just fresh from the oven. I run this last night. This is the history of the air quality index for ozone from 1980 to 2024. And I really like this picture because it shows the stational variation of ozone in time. You see on the top you have January, and at the end you have December, and the purple is really bad, the green is really good, and how we have been progressing in terms of controlling air pollution for ozone. This is for the Los Angeles, Long Beach, and Anaheim area. The maximum for that time compared to the air quality index. And then the next one, please. So we have the seasonal variation, and then we have the variation over time. If you see in this chart, the top, the blue line correspond to the basin ozone design value. It means the air quality, which for ozone, the air quality standard for ozone is defined as the fourth maximum 8 hours running average and an average over 3 years. It's a little bit confusing, but just imagine that you have the fourth maximum for each year in your basin, and then you have a little running average of 3 years to achieve that. And we see a little bit of increase in ozone in the later part. In 2020, we have seen that it's going up a little bit, and then on red we have anthropogenic reactive organic gases, which has been declining steadily, and then we have the anthropogenic NOx emission, which also has been reducing drastically, and then we have a baseline of biogenic organic gases. We cannot do a lot about the background of organic gases, but they are going to be there. So even if we remove all the reactive or organic gases from the anthropogenic sources, we would have some ozone. So this is the temporal variation, and could you do the next one, please? And then we have the spatial distribution of ozone in Los Angeles area or in the South Coast Air Quality Basin. In 2000, we had a broader extension on the air pollution for the 8 hours moving average. You can see the region to the east of the basin highly impacted, and then we see the improvements by 2020. But if you notice the Los Angeles area, which is the little green dot, it went from 0 to 0.065 parts per million to 66 parts per billion to 70 parts per billion. So it increased the background in Los Angeles area while reducing in the rest of the basin. So we have a seasonal variation, we have a temporal variation, and we have a regional variation, and we have impact of different people in the basin. It was mentioned that 90% of the people is exposed to harmful levels of ozone. The same thing is happening in Los Angeles, and we're trying to reach the air quality standard. Next, please. So we have the precursors into the left. We have the nitrogen oxides, and to the right we have the reactive organic gases. And another important part is these are not linear process. In the below to the left, we have the ozone isolates. These are the predicted emissions to reach the air quality standards by 2037. So this would be the isolates of Glendora, which is one local place, and you see the ECMA model or the isolates of ozone. And in some regimens, if you reduce NOx, you could increase the ozone, and vice versa. We're reaching the point of NOx limiting. So by reducing NOx, we're going to achieve lower ozone levels. To the right, we have the expected attainment on the basis. And you can see that the most population in California are exposed to ozone, and then we have different timelines to reach the air quality standards, being Los Angeles and the San Joaquin Valley the more severely impacted, and we're expecting to reach this, if everything goes fine, by 2037. And what do I mean by if everything goes fine? Next, please. We not only need all the actions in on-road, heavy duty, light duty, consumer products, paints, large combustion sources. We need regulation. We need incentives, monetary incentives and fiscal incentives. We have to control the growth of Los Angeles, which is increasing every time. So all these achievements have been done under a very high population pressure and the increase of the vehicles miles travels per year, removing all the older vehicles, and having exchange programs for older vehicles for new electrified vehicles. But also we need to put all the necessary resources to achieve the goals. We need a cooperation from all the sectors, the public, the local, the state, the federal actors, and in some cases, the international actors. For example, in the case of ocean-going vessels, we need to keep the scientific and socioeconomic information. We need to know where we are in the ECMA, where is the regimen that we're having, where are the sources that we're not accounting in the emission inventory. We're preserving environmental justice. Not everyone is impacted in the same way. In the western part of Los Angeles, where all the houses that very sadly were burned in the recent years were impacted, but low-income people live in the western side of, in the eastern side of Los Angeles. So we need to keep focusing in environmental justice. And we have the challenge of climate change. The globe is warming. So we have these challenges that we need to address. The final one, please. This is a verse from Proverbs that I really like, which is, where there is no vision, the people perish. So important thing is to have a clear vision on how to clean the air, how to address these issues. And I applaud the incentive that Rodolfo is leading. Thank you very much. This will be my final slide.
Oh, thank you. Thank you very much indeed, Dr. Cicero, for summarizing a complete history of ozone control spanning over 70 years, or no, yeah, 70 years in such a short time in this event. Now I will kindly ask Patricia Camacho from Mexico City to proceed with her presentation. And by the way, today, there is an air quality alert in Mexico City, and at least 20% of vehicles, perhaps 2 million vehicles, are not allowed to circulate due to high ozone concentrations. Well, Patricia is a hydrobiologist from the Metropolitan Autonomous University with a master's degree in civil engineering, specializing in environmental issues. As mentioned earlier, she currently serves as the Director of Air Quality Projects for the Mexico City government. She has extensive experience in developing emissions inventory for atmospheric pollutants, greenhouse gases, and toxic components or pollutants. Patricia leads the coordination and implementation of air quality plans, programs, and projects in Mexico City, and she is also a certified specialist in greenhouse gas emissions inventory for cities, specifically for cities, and she is an environmental regulator for the transportation, the industry, and the oil and gas sectors. So, Patricia, the floor is yours.
Thank you very much, Dr. Lassi. I'm going to share my presentation. Could you tell me if you can see?
Now we can see it.
It is fine in this way?
I think that you have to put it in the full screen mode. Yeah, that's right. Thank you.
Okay, thank you very much. I really appreciate the invitation to share the experience and the opportunity to share with you the improve of air quality in Mexico City. I would like to start with this picture in the left side. We have the city so many decades ago. At the end of my presentation, we will see how we are right now, even with the high episode of the ozone that we are in these days. We were considered in that time the most polluted city on the world, so that the government started to apply many actions, and you can see in the chart, Mexico City had been historical decrease in all pollutants. However, the particles are beginning to increase, and the ozone, the red line, has been stabilizing. Mexico City have implemented many actions, some very similar like LA and Los Angeles, sorry. But I'm not going to mention each one. I just focus in the most important or the most effective to reduce the ozone precursors. In Mexico City, in the 90s, we started with two fundamental programs for the transport. One of them is the smoke check. In this program, where we check every 6 months the car's emissions, and it is very related with the second important program, no driving day program. Both of them are applying right now, and in this driving no day, the most polluting or the oldest vehicles have a restriction of circulation for 1 day. Also, the government started to develop national standards since that time, and in order to limit the vehicles emission, because this sector, the transport sector, is a national level. Additional to these two programs, the government works to improve the quality fuels. The most remarkable was the elimination of lead, the reduction of sulfurs and olefins. The olefins are a VOC group better reacted to the ozone formation. This action allowed to introduce vehicles with better technologies And right now, we have the newest fleet in the country. Other major action that we or the government implemented was the installation of the vapor recovery system in the gas station. This was in order to reduce the evaporative emission from gasoline. As you know, the gasoline have this reactive compound to the ozone formation. And the gasoline have a toxic compound with very impact to the health. Speaking about the industrial sector, the action started with the closure of the refinery. This refinery was located in the center of the city in that time. And with this, another several industries were relocated outside of the city. In these sectors, additional, the government developed some standards to control the primary emission because you know we have the primary emission and the secondary pollutant like ozone. And many years ago, the Mexico City government as a local government started with the local standards in the industrial sectors. Even with all of this action, improve the air quality remains as a challenge, and we still have high ozone concentration in the hot season. We started right now with the hot season in Mexico City, and here comes another additional factor, the climate change, which result in something called the ozone climate penalty. In the first presentation, we saw how the ozone impact on the global warming, and here with the ozone climate penalty, we can see how the climate change impact on the ozone. So what does that mean? It is how much ozone is caused by the climate change, how the ozone is impacted by the change on temperature, precipitation, weight, etc. Scientific evidence has documented between 2 and 12 ppb of ozone are due to the climate change. In international research, 1 degree in the average temperature could cause an increase of 2.9 ppb of ozone. In Mexico City, a study determined 8 ppb by 1 Celsius degrees. We need to make some scientific research to know how is the atmosphere in our city, on our country, because we need to know it is limited by NOx, NOx, or limited by VOC. With that, we need to be careful to choose how strategies we need to implement in order to reduce the ozone formation. With all of this on mind, we developed the air quality program for the following years with the aim to recover the trend of the reduction pollution, and we established a reduction between 20% to 25%, depending of the pollutant. We focus this program in the most polluting sector of particles and the ozone, of course, its precursors, with some complementary action, such as regulatory agenda and research agenda, because it's necessary to formulate action based on the scientific evidence. In Mexico City, we need to explore more about the photochemical reaction on the atmosphere, and it's very related with the climate change. I'm not going to mention each action, but we are attending the most polluting sector, like the transport, industrial and commerce as service, waste, in order to attend the emission of the methane, the domestic sector, we have more than 100 action in this air quality program. The air quality program was evaluated in terms of the emission reduction and reduction of concentration. With this, you can see how is the business as usual, the green line, and the blue line, how will be the emission if we implement all the action in our air quality program. After we made a modeling in terms of the photochemical reaction, and we established the reduction of PM 2.5, reduction on NOx, NOx and VOCs, and the maximum of the ozone. In terms of the impact head, the evaluation program results around 6,000 premature deaths that could be avoided in 2030. Even with the evaluation was made only for this year, we have a prematurely avoided death. The evaluation was made by each pollutant, but we take the biggest number. And something important, we don't recommend to add this number. We just take the biggest number. The program was evaluated in terms of the concentration reduction on health and result in a higher cost benefit action. The best to reduce NOx, is develop or update the regulation for industry, power generation plant, and freight transport. For VOC, we are focused on creating regulation to limit VOCs on domestic consumer products, such as pesticide, coating, cleaner, cosmetic, in the others. Finally, as part of the recommendation for other countries as a very general action that we are right now in the city, we need to move to electromobility in public and private transport, creation of the cable cars, electromobility too, voluntary programs to freight transport, as well updating standards for transport, a product with VOCs. This last one must be in coordination with the federal government because they are sectors that no have obligation with our local government. All of these strategies must be evaluated and verified and supported by scientific community because we need to have this support in order to modify the action if they doesn't work. That's also for my part. Thank you very much.
Well, thank you very much, Patricia. I know that we have
Sorry. You can see in this picture how is the Mexico City right now in these days. Thank you.
No, thank you. I know that you have to move now to attend this environmental contingency program that you are facing in Mexico City. So
yes, thank you.
Oh, thank you. Have a nice day. Now I will ask Dr. Juan Mata to give his presentation. Dr. Mata is a specialist in energy and environmental issues with over 25 years of international experience in developing public policies, regulations, programs, and projects for government, businesses, and multilateral organizations. He has worked intensively and extensively with the IDB, with the World Bank Group, and United Nations agencies such as the UNDP and UNOPS, among others. He has held senior positions in both the public and private sector and has represented the Mexican government in multilateral expert groups on energy, environment, and climate change. Dr. Mata holds a PhD in environmental engineering from the University of Maryland in USA, and he is also the author, editor, and contributor to more than 25 technical and scientific publications on energy, environment, and sustainability. So, Dr. Mata, the floor is yours.
Thank you very, very much, Rodolfo. And first of all, I want to thank the Clean Air Institute and the Clean Air Task Force for inviting me to participate in this webinar. I don't know if Karen is going to upload my presentation. Is that correct?
Let me 1 second.
Yes, thank you very much, Karen. And first of all, I mean, while she uploads my presentation, which is now it's ready, I will try to summarize in these 10 minutes or 12 minutes that I have to give my presentation. I will summarize sector by sector some of the key opportunities that can be enforced, intensified, or adopt in order to address both climate mitigation and in parallel address the reduction of tropospheric ozone precursors. Of course, I will go sector by sector. I know that sectors are not isolated, and this work of addressing both ozone reduction and climate mitigation needs a cross-cutting view from sectors that can live together in specifically in urban metropolis. But also, this is insufficient if there are not a cross-cutting work or cooperative work among federal governments, local governments, the private sector, and of course the local communities. So this is something that I will be addressing throughout my presentation. And of course, in order to have the proper strength at a global level, it will be necessary also to reinforce some of the international agreements on climate change and pollution prevention in order to address the possibility of work jointly between climate change mitigation and the reduction of tropospheric ozone. So can you move to the first slide, please, Karen? Of course, I will go ahead first on the opportunities on the power supply. Power supply, there are two avenues right here three avenues of possible actions that include both the transition to new technologies, but also the upgrading of existing technologies and best practices. First of all, on the opportunities for power supply, it is necessary at global level to intensify the use of renewable energy, to have a more accelerated renewable energy transition. Also, it will be necessary to upgrade grid infrastructure because, as you know, except from large hydropower or geothermal technologies, most of the renewable energy technologies are not base technologies. They are intermittent. So you need to have a more sophisticated power system to dispatch intermittent and deal with intermittency of renewable energy technologies. At the same time, it will be necessary also to work jointly with the urban governments in order to promote more distributed energy sources in houses and in buildings in general, promoting small-scale renewable energy, specifically solar photovoltaics. And also, in order to prepare for the transition in the transport sector to electric mobility, which is another type of action that will be necessary to move forward, as mentioned already by my colleague from this presentation from the cities of Los Angeles and Mexico. It will be necessary to enforce the supply of electricity in the houses in order to have the capacity of recharging electric vehicles once they are promoted and disseminated in the cities. At the same time, there will be still a need to work in the end of pipe of power facilities in order to limit the emission of ozone precursors like NOx, for example, if more combined cycle plants based on natural gas are implemented, for example. This is another thing that needs to be reinforced and mostly in developing world. Next, please. For opportunities in oil and gas and industrial facilities, basically what is needed to do is to work more intensively in reducing the leak of methane coming from the oil and gas industry and from the industrial works, and also the possibility of a more cleaner oil and gas extraction technologies or clean production technologies and in the industry sector. The switching to more clean fossil fuels like natural gas or the use of alternative biomass-based fuels. It is also necessary to reinforce the use of end-of-pipe control technologies to limit the emissions from VOCs in the industry, like using scrubbers or catalytic converters, and also to install more best practices of reducing energy consumption, making more industrial production systems by using or recycling or reusing materials and energy. Thank you. The next one, please. As for the opportunities in buildings, basically what is needed to do is to work more intensively in the design of new buildings to improve passive systems to reduce the consumption of energy in heating and cooling, the use of more energy efficient appliances, and also something that this is very important is the transition from gas-based electric heating and cooling and cooking to more clean electric devices, for example, because in this case, in the building sector, the fugitive emissions of natural gas or LPG is an issue for the formation of a troposphere ozone. At the same time, as I mentioned, it will be necessary to prepare the buildings and homes and also the commercial buildings to support electric vehicle recharging infrastructure. The next, please. As for example, for opportunities in the urban transport, which I think it's something that is key in order to limit the formation of tropospheric ozone in cities. On top of that, electric vehicle, electrification of electric vehicles by widespreading its adoption is something that it is necessary, but this will not be possible in cities that are not prepared to have the recharging infrastructure in houses or in public buildings. So this is something that will be very necessary to prepare in parallel. At the same time, I know that this is not a silver bullet. This thing has to be accompanied with policies and more strong policies to keep on updating and modernizing the public transportation, expansion to more clean technologies like BRTs or trolleys or invest in metro systems. And also it is important to adopt sustainable urban planning for making lanes more walkable or biking friendly. At the same time, it is important to strengthen also the limit of vehicle circulation, like establishing more strict standards for vehicles and limit the circulation vehicles by time, as the Hoy No Circula in Mexico, or by zone in some cities like London that have been implemented very successfully in the past. Promoting carpooling and ride-sharing programs is also very important to limit the use of vehicles in urban areas. The next one, please. For agriculture and waste, I think agriculture and waste are key sectors because are responsible for one of the most important tropospheric ozone precursors, which is methane. On the agricultural sector, it is very important to limit, for example, the more efficient use of fertilizers, which is something that are fertilizers are known to induce the formation of NOxes, which is a precursor of ozone. And at the same time, it is necessary to improve more sustainable agricultural and livestock management practices to reduce the production of methane emissions. At the same time, it is important that on the side of waste, be able to capture methane on landfills and on wastewater plants, and use this biogas to produce energy. So waste to energy technologies is very important in this sector. And at the same time, to induce the use of more sustainable waste practices like the recycling, the reduction initiatives, and like encouraging reusable products or reduce the packaging. And this of course will not be possible if there is no collaboration with the public, like an engagement to create public awareness campaigns, and also waste reduction, recycling, and proper disposal education to the public. The next one, please. As for the public and private sector involvement, which is something that is key, it is important in order to deal with this, to move forward with corporate responsibilities. It's important to encourage businesses to reduce emissions and invest in clean technologies. At the same time, it is necessary to attract the private sector for private investment to channel sufficient resources for climate solutions and reducing the tropospheric ozone. It is important to promote and support startups and technologies to address greenhouse gas mitigation and ozone reduction, and at the same time, be able to attract the public with the engagement, with education and health, environmental impact education programs, incentive programs. For example, it is important to incentivize consumers and businesses to adopt low emission technologies by giving incentives, fiscal incentives to new technologies, clean technologies, but also taxing the obsolete practices and reduce the subsidies and removals to fossil fuels. This is something very important. And also, it is important to create global coalitions between international organizations, NGOs, local governments, for the advocacy of policy changes and awareness campaigns. The next one, please. I think one of the key things that needs to happen in terms of channeling financial resources is how to modify or shape the existing carbon pricing instruments and financial mechanisms on climate change to include actions that will in parallel address both greenhouse gas mitigation and at the same time reduce ozone precursors. And for this, it is important to modify or adapt carbon taxes in order to incentivize the use of fossil fuels and move forward to schemes of ETS, emission trading systems, and cap and trade systems in order to address this. At the same time, it is necessary to continue funding ozone reducing projects and allocate carbon finance to those projects that could in parallel reduce both ozone precursors and greenhouse gases. The next one. And so lastly, I think this is not sufficient if you don't address or collaborate with existing international agreements in order to address tropospheric ozone. And that it means it is important to work together with the Montreal Protocol, which is still working, and there are amendments to this Montreal Protocol. One example is the Kigali Agreement, and to move forward also to expand this very successful model to phase out ozone, tropospheric ozone at the same time. I think it is also important, and I know that your coalition has been working jointly with United Nations to enforce or amend the Paris Agreement in linking the efforts of reducing ozone precursor emissions with global climate targets in specific articles of the Paris Agreement to address this in NDCs, Article 4, cooperative approaches, including the market approaches of Article 6, the transfer of technology on Article 10, the public participation and education on Article 12, and transparency framework on Article 13. Those are some examples. And another one, which is very important, is to work together to address in the United Nations Sustainable Development Goals, the tropospheric ozone reduction in some of the SDG frameworks, especially the one dealing with climate action and the one that has to do with good health and well-being. I think this is the end of my presentation, and I hope I have not taken too much more time, and I'm ready for any question or comment. Thank you.
No, thank you, Dr. Mata. Well, we will have our Q&A session, but now I would like to open the floor for interventions from representatives of cities or metropolitan areas concerned about their ozone issues. I don't know if someone would like to share a few brief remarks with us. If not, I don't see any raised hand. Oh yeah, Ramiro Barrios. Ramiro, can you take the floor, please? Please be short in your remarks because we are running out of time. Not too much, but
yes, thank you very much, and thank you for the invitation for this seminar. I just want to stress that the presentations are very complete and there is a lot of information, but something that I want to stress is the need for this metropolitan vision, like in Mexico City. It's not just the government of Mexico City, but also the government of the state of Mexico that are working together as the Valley of Mexico in order to address and to reduce ozone precursors. I work here in the Megalopolis Environmental Commission, which also includes the 6 states that are surrounding Mexico City and the state of Mexico. So the idea is ozone precursors have to be reduced in all these areas, but also the fact that ozone formation regimes can be different in different areas. So in some areas, probably you need to reduce organic volatile compounds, and in some areas, probably you need to reduce first the oxides of nitrogen. So it is very important, this geographical distribution. So thank you very much again.
No, thank you, Ramiro. Sorry, I was distracted. But after these enlightening presentations and policy and strategies to mitigate tropospheric ozone and its precursors, let's proceed to the next item on the agenda. And you know that an interdisciplinary team, yes, from Kai, from Hill, in collaboration with experts from diverse organizations and regions, is developing a blueprint to foster international consensus and cooperation on mitigation or mitigating the impacts of tropospheric ozone from 2025 to 2028. So Dr. Monica Espinosa will now share further insights into this initiative. Monica Espinosa is an environmental engineer with a PhD in engineering. She has experience in conducting technical analysis to support the nationally determined contributions, NDCs, building process in Latin America. So Monica has also participated in the development of various local air pollution management plans. And in this project, she is part of the team working on the blueprint for tropospheric ozone. Monica, the floor is yours.
Thank you, Rodolfo. I'm going to be very brief because of time. So I'm going to share my presentation. Okay, so, as it has been mentioned before, there are several reasons that are supporting that there is still the need to tackle tropospheric ozone in a more effective way. We have examples from diverse cities around the world showing that tropospheric ozone has been often driven by the air quality field and at the local and subnational level, but we still have a challenge into achieving the lower levels of tropospheric ozone. So the need is, as Italy explained, to comply with the climate targets. The short-lived climate pollutants need to be tackled. It is not an option, it's a must, but because there are many other co-benefits in terms of health, crops, forest, among others, there's also the opportunity to work together with a more integral view. And it means, as Dr. Juan Mata has just explained, that we need integrated actions and a more integral view in terms of air quality management and climate change. So because tropospheric ozone is in the middle between climate change, air quality, public health, agriculture, it means that we need to involve several stakeholders if we want to really tackle or involve tropospheric ozone into the global climate agenda. So we have been working under the leading of the Cleaner Fund in collaboration with the Cleaner Institute, the Cleaner Task Force, and HIL in developing a blueprint. This blueprint, its objective is to set which should be the activities to implement in the next years if we want to include tropospheric ozone into the climate agenda, but with a more integral view. So this exercise is being in several work streams. We are working in particular in 3 work streams to decide which should be the actions that need to be implemented in the following 3 years. The first work stream is research. We also have this policy and regulation work stream and implementation. And I think that the examples that we have just seen and the opportunities that we have just seen are showing us the different and huge challenges that there are still on the table and need to be solved in the following years if we want to tackle this objective of controlling tropospheric ozone. So at the end, with this tropospheric ozone blueprint, what we want is to propose a route towards achieving the international consensus and cooperation that is needed to advance on tropospheric ozone control. There are several participatory processes going on to gather very diverse range of perspectives because we want to have people from different sectors and from different types of institutions participating in this exercise. Some of you have already been contacted to participate in focus groups. This activity will be conducted in the following weeks, but there's also an exercise that will be in the framework of the second Global Air Quality Conference with an advisory group. And the activity that we would like to present today and invite you to participate is an online survey. That survey, we are going to share with you the link into the chat. That survey is also structured in 3 main work streams that I mentioned before: policy, science, and implementation. And you can fill in the parts you feel more comfortable with. So we have some parts of that survey are designed for experts, but if you are not an expert on any of them, you can skip that part and then go into the final part of the survey, which is open to everyone to contribute to share your ideas on how we should work with a global view and a more integral view in terms of climate change and air quality to achieve this goal of having ozone into the climate agenda. The survey will be open until the next March, so please feel free to come into the survey to participate and collaborate with this task. And we will be sharing results in a couple of months when we have all these inputs to finish the blueprint. So I was very brief, but it was because of time. So thank you, and please participate collaborating with these inputs.
No, thank you very much, Monica, and I really encourage all the audience and all the participants to fulfill this survey. Our goal is to address the key questions that are part of our problem. How can ozone precursors be reduced in urban areas that comply with air quality standards, but whose emissions are transported to rural areas where ozone formation is more likely and negatively impacts ecosystems, agriculture, and communities? Of course, we would like to know from your experience what have been the most effective strategies for ozone control that successfully engage both communities and local authorities, and which financial and organizational initiatives, whether governmental or private, related to electromobility, for example, or sustainable mobility, are best positioned to drive the widespread adoption of zero emissions vehicles or zero emission alternatives. Well, to conclude, I would like to express my heartfelt gratitude to all these distinguished panelists, to our multi-organization team, and to all of you for contributing to this enriching and thought-provoking discussion. It has truly been a privilege to engage in such a meaningful dialogue. Now I'm pleased to pass the floor to Juliana Klackkamp. She is the CEO of the Clean Air Institute, who will deliver her closing remarks to bring this event to a fitting conclusion. Juliana, the floor is yours.
Thank you so much, Rodolfo, and thank you all for joining today's discussion on mitigation strategies to reduce local ozone impacts on climate, air quality, and health. The insights shared today from cities and organizations with decades of experience in ozone control actions have provided invaluable lessons, highlighting how targeted strategies, innovative policies, and strong governance drive progress. As we move forward, as Monica mentioned, we are working in this blueprint for tropospheric ozone, and we are also defining, digamos, what are the actions needed in the coming years. As we move forward, I encourage continued engagement, strengthened partnership, and collective efforts to implement effective mitigation strategies. I wanted also to mention that your contributions are critical in shaping policies that improve air quality and advance climate commitments under the UNFCCC and the NDCs. We will remain in close contact to share progress and results from this large initiative. And I also wanted to express a special thank you to all of our speakers, panelists, and our organizing partners, the Cleaner Fund, the Cleaner Task Force, and Hill Consulting for making this event possible. So I just wanted also to mention that let's all continue working together towards a cleaner air and a healthier planet. Thank you, planet. Thank you so much. Rodolfo, I also think we will share, I see there are some of the questions that haven't been responded, so we will share our responses by email. If it's okay, I think we will ask the panelists too.
Yeah, we have been answering all the questions that you posted in the chat, but as Juliana is saying, we will send the answers to you directly. Thank you very much indeed. Have a nice day.
Bye-bye.
Bye-bye.
Thank you.